Hello everyone, my name is Roger Fari, and in this video we are going to talk about errors in Python. So as you are watching this video in this series of videos, I would make a good guess that you are rather new to programming. And one of the things that I would like to give you as an advice as you're starting on this exciting journey is to welcome errors, see errors as an opportunity for learning, and do not let their ugly look or their unexpected appearance to become a barrier in your learning. So in that regard, I have put together this video that's going to educate you to a very good extent about errors, to understand what they are and what is their purpose, and see their different types and how you could go about dealing with them. So let's look at what we have in this file. So in Python and in general, actually in any programming environment, we have three types of errors: syntax error, runtime error, and semantic error. A syntax error is when you have not written your code in accordance with what the programming environment expects, right? So for instance, in this example, we see that you say print hello. And normally when we want to print hello, what we have is parentheses. Printing is a function, and it requires a parentheses, right? So once you run this, it gives you a syntax error, right? It means that the program does not recognize the typing of this code that you have. There is another type of syntax error that is still a syntax error, but it has a more meaningful and more specific message, is indentation error. This error happens when you have a mistaken indentation. Here on your for, on the for loop that we discussed in the previous video, we need an indentation exactly like this. But when you don't have it for any reason, when you run that, it's going to give you another syntax error, but this time it's going to say indentation error. So syntax error are the types of error that does not even allow your code to start running. The compiler checks your code to make sure that you have adhered to the agreements and the rules of writing a code. If you haven't, example such as these, it's going to raise a syntax error. Contrary to syntax error, runtime errors are different. Runtime error happens when you have actually an error that the compiler is going to only get to understand or see that there is an error there when you have actually ran the code, right? The syntax wise your code is good and it start running and it start actually doing things, right? So that's a very important distinction to see the difference between syntax error and a runtime error. So we have a syntax error here and we have a runtime error here. We will see why this is an error, but let's just see the comparison between the two. So if we run the first code here, when we run it, of course there is a syntax error, it's not going to run, but it tells us there is a syntax error here. Pay attention, none of these four codes that are okay has been run because there is a syntax error. But when we have a runtime error, right, so this line is going to create a runtime error, and specifically because we have not defined this variable yet, right? So it says, what is this, right? It says a name error. Name, my variable is not defined. But pay attention to the distinction. The distinction is these four lines were run. And then it come to this point that it realized there's an error, right? I mean, as far as the syntax, everything looks okay, but there is no way for the program to see that there is no such thing as my variable. It has to only be done when you have ran this, right? So that's the difference between syntax error and a runtime error. There are many different types of runtime error in Python, and we are going to go over them together here. So the first runtime error is name error. It's just what we saw, and it happens when you are trying to reference or call something that is not defined yet, right? So here, for instance, I create my variable and I use a Pascal case, right? And then mistakenly I want to reach my variable with the camel case, right? So there is a difference between this, lowercase m and this uppercase m. And because of that, it says, I don't recognize this my variable, right? And that's why you get a name error, and this is a name error. Of course, for you to fix this, you have to, let me keep the error. You have to switch this to my variable, right? And then this is going to run. The next error we're going to discuss is attribute error. Attribute error is similar to runtime error, but any data object in Python may have some attributes such as properties or functions. For instance, a list that we'll discuss in the future video, it has a attribute function append. Basically, when you have a list, you can add more value to it, right? So I have this list, and then I add append 6. So when I run it, it will give me the 6 here, right? So append is an attribute of a list. But, because I don't know any better, I create my variable and I try to add with using the function append. And because my variable, which is type integer, right, does not have this function or this attribute, when we run this, it's going to give us attribute error. Int object has no attribute append, right? So this is attribute error. And of course, the way to fix this is just know that int does not have this function. We need something else, or this is not logical. Something logical to do. Maybe we need a list here, right? So we need to switch this into a list, right? So one of the things we could be doing to fix this is, have the clarity that this is what we need. This is a list, right? And then use the append. Once we run this, now there is no error. And we can see that we have 7 and 8. Another very common error is ModuleNotFoudError. Module is a series of classes and functions that have already been set and written and developed. We can just access to use them. For instance, we can import datetime, which is a module. They can help us with datetime. For instance, it can tell us what day and time it is right now. So this is the day and time that I'm making this video, right? If we were to import a module that does not exist, such as something random as this, right? When we run this, it tells ModuleNotFoudError, right? This type of situation rarely happens. What actually happens is when we have a typo in a module that we know that exists. We have datetime, but here it's data time, and then when you run this, it will give you that ModuleNotFoudError. Another error that is very common is IndexError. It's also another runtime error, and it happens when you work with objects that has index. For instance, a list. A list is a collection of items that you have that collection, but at the same time you can access them using the index. For instance, you say bracket 0, it will give you access to this value because this is index 0, index 1, 2, 3, and 4, right? So once I run this, it will give me access to this value, right? Once I run this, it gives me access to this value, right? But if you try to access something that does not exist, there is no such thing as index 5 here, it will give you this error, right? index range out of range, list index out of range, index error. The next error we're going to talk here is about key error. Key error happens when your object that you're working has keys. There is another thing we are going to learn in one of the future videos is a data structure called dictionary. A dictionary, like a dictionary, is basically has a key and a value, right? For instance, I have a dictionary of words that are about good taste, right? So I have scrumptious, this is the key, and extremely tasty, delicious, this is the value or definition. And then I've got mouth-watering, smelling, looking, or sounding delicious, it's the key, the value, right? I have appetizing, key, the value, stimulating one's appetite, right? So once I run this, I have created this dictionary. Now I can access the values using the keys. For instance, I say, what is appetizing? It tells me, stimulating one's appetite, right? Exactly the value. But if I try to access something that there is no key or value for it, this is the error I get, key error. There is no such key, right? So that's another error. Another runtime error that may happen to you is when you have to stop the kernel, manually, right? For instance, if we have this function run, what is going to happen? This is going to be an endless loop because we are not stopping this while loop at any point in time. It's always true. So for us to stop this, as we saw in the previous video, we would have to shut this off manually. Once we do that, this is the error we get. Keyboard interrupt. We interrupted the running of the kernel. Another error we have is memory error. This is when you run out of memory on your computer. Your calculations, computations are just too much for your computer's memory capacity to handle. The other error we're going to discuss here is overflow error. This happens when you have mathematical operations that reaches their value are just too large for Python to be able to handle. For instance, if I get the exponential of 1000, this error is going to happen. If I get 500, this is not going to happen. It's going to actually give me the value, which is such a large value. But there is a limit, and that limit can be reached at some point when we have 1000, right? So that's when you get overflow error. Stop iteration. This error is a specific error when you have iterators. One of the iterators that we're going to discuss in one of the future videos is mapping a function to a list, right? So I have my list and I want to map a function, which is the math exponential, to this list. If this goes over your head, just don't worry about it. Just give it a minute. And once you run this, you will have a map, and now you can start running this math exponential function for each of these values, right? So when you say next, it will run it for the first value, for the second value, for the third value, for the fourth value, right? And then if you run it again, you run out of values, right? So that's why it says stop iteration. So that's the error that you get when you get into these types of situations. Type error. Type error is when you are trying to do a function, but your input is not the appropriate type. For instance, this function int, when you want to run this casting function, it just wants one value. It doesn't want the collection of value. Once you do that, it says, I'm expecting another type, right? I'm expecting just one thing. If you were to run something like this, it would just run for you. But even though there is sometimes just one value, right? The value has to be specifically correct, right? If you were to do this, right, and run this, it says value error. The type is okay. I mean, you can pass string, right? But this is no number. And that's when Python will tell you it's a value error. Another error we're going to discuss here is UnboundLocalError. This error happens when you have a function, and inside the function you want to change the value of something that you have not defined in the function, right? So once I run this, I never define x, right? I mean, the function Python, we said, okay, this might be a universal variable, right? So this variable has never been defined in this, but this might be a universal variable. That's why the function, let it be defined. But once you try to run it, it says unbounded local error. I mean, you never defined x and you're trying to do things with it. And that's the error you get, unbounded local error. Zero division error, of course, whenever you end up dividing a number with 0, this is the error you're going to get because the result is infinity and there is no such thing. That for you actually have infinity in numbers, that's why you get the error, zero division by error. These types of runtime errors that we saw, these are some errors that Python have done an excellent job of categorizing, but there might be more of situations that you run into runtime errors. For those cases, you're going to have just to see this runtime error. I mean, it's not going to have a specific type of runtime error, and that's how this is designed here, right? So that's, it's a runtime error, but this is not one of these classified errors that we've seen. Another thing we want to learn in this video is how we would go about raising an error ourselves. This is perhaps a little bit advanced in this level of you learning about programming in Python. I'm just saying this to give you perspective, not expecting you to actually do this yourself. So here, what's happening, I have created a function, right? And I'm creating this function to tell me if a number is odd or even, right? So, I want to let this function to be used later on. I want to, give it to other people to use it, right? So, before checking if this function, if the number is odd or even, I want to make sure that a number has been and an integer has been put here, right? A floating point is not a integer for you to be saying, oh, odd or even. So you need an integer, right? So if the input is not integer, you raise an error yourself, right? You say runtime error, show me this. So the function you created has the potential to raise its own errors. When you run this, now it raises this error, runtime error, and it just raised exactly the message that you put here, right? It says you can only use this function with integer values. And this is that runtime error, the sort of like the general runtime error. But isn't this a case of value error that we learn? We could go with our better understanding of these error structure. We can actually raise a value error, because this is a type of value error that is happening with our function that we're defining. So we can actually do a better job creating these errors. Once we run this, we've got this value error here. All right, so the last error we're going to discuss is semantic errors. Semantic errors is different to syntax error and runtime errors, is because when you have semantic errors, your code runs and there is no error message, but your code does not run the way you wanted, or the answer is incorrect. You just are not getting what you expect. And the reason is not that you have a problem with the programming aspect of the code. The reason is you have a logical error in your program. So for instance, let's use the function that we just created, odd or even. And once we run this, it tells us odd, and we do know 10 is even, right? So what's happening here, right? Let me copy this code and bring it here. And when we look closer, we do see that when the numbers, the remainder of division by 2 is 0, we have to report out even, right? So we've made this logical mistake, and that's why this is a semantic error. But we can of course fix it, and once we fixed it, now once we run it, now this looks okay. A second example we can see is the example that we actually saw. It was an example of errors. It was an error we saw during the video. We were looking at loops, and we had created this loop to, would calculate the summation of odd numbers from 1 to 30, and we had to use these three keywords or lines of code. And when we would run this, we were expecting to just get the answer, but what would happen, it would be an endless loop, right? It would create an endless loop. When we have this asterisk or star sign just remaining here, it means that this is running. We're not expecting such a long run for this very simple program. Therefore, this is an endless loop, right? So we can stop this, and here, it's a semantic error. When you have a semantic error, you want to be able to do some detective work. One of the detective works that you can do is to see where is your counter at, right? You shut the code at some point, right? So you can open a new chunk and just see where I is at, right? And it tells you it's this big number. So for sure, this has been an endless loop, and I has been kept adding here, right? So one of the things that we can also do as a detective work is to create some sort of reporting out for ourselves to see what's happening in the code, right? I can, one of the things I can do, I say print I, and once I run this, I can see that I is only being printed out as 2, 4, 6, 8. These are only odd, even numbers, right? And because I never gets to be 30 here, right, before this, so let me change this to here. Let me change the print I here. Never gets to be 30. It never has the chance to shut this, right? This is our structure to stop the code, to stop the loop, right? To fix this, I can simply switch this from I is equal to 30, from I is greater than or equal to 30. So once I run this, now my code does not have this logical problem, right? It answers the question, and it just works fine now. So I can remove this. There we go. Example 3. In this example, we want to be able to find the maximum value in a list, right? And this is the code that we have created, right? So once I run this, I'm expecting to see the answer as this 100,000, but it's giving me 0. So even though the code looks completely okay to me, but something is not right. So we could also do with the same thing that we did with printing out something here, but there is another tool we can use, and that tool is setting trace. We can use the module PDB to trace our program during the runtime, right? So let's just run this, and we have to import this and also put our trace at some point during the code. So once we run this, what's going to happen, the code is going to run until that point, and now you're going to have some control. You can see what is the value of num, right? It tells you num is 20 right now. You can see what is the value of contender, so on and so forth, right? Contender is 0. And you can also say step, as in go to the next step, right? It goes to the next step. We can keep saying step, step, right? It goes to the next step, as in it goes to the next line. Or you can say continue. And when you say continue, this is going to continue running until it comes back to the trace again, right? So it comes back to tracing. And so let me say continue a few times. If I were to say num now, once I say now num has changed, has moved from 20 to this, and now I would expect the contender to have shifted from 0 to this number, right? Because this is the biggest of all of them. So once I run this, I see still this is 0. So I start wondering what's happening here. If contender is larger than num, oh, that's a mistake. If the contender is smaller than num, right? So by using a trace, I can figure out what's happening here and what's the problem, right? So I can simply say run. So this is going to run, and I can, get rid of this and get rid of that and change this to this, and now this is gonna run correctly. All right, so in this video we are able to talk about errors and see 3 different types of errors and have some understanding of them, at the same time know some techniques how to deal with them. All right, until the next video.